Alright, so today we are starting a unit on circles. We're going to be talking about vocabulary, basic stuff you need to know about circles, and then we're going to jump straight into tangents of circles and do some practice together, and then we'll be able to knock out an assignment. Make sure you have your note sheet you grabbed on the way in. If you're finishing a test, continue to finish that test because it needs to get done today, please. So let's take a look at our note sheet. Looks like this right here. Let's talk about some vocab, all right? So again, talking about circles, number 1 for vocab. Everything's on there already for you, okay? So everyone's looking up here, not our phones. Number 1 says circle, the set of all points in a plane that are equidistant from a fixed point called the center. Okay, so if you want to know how do you get a circle? It's equal distance from one point all the way around. Makes a circle, okay? And we know what a radius is, hopefully, a segment whose endpoints are the center and a point on the circle, okay? Basically, it's halfway across, through the middle. Note, all the radii of the same circle are congruent. So radii is a fancy way of saying multiple radius, okay? It's plural, so all the radii are equal, because that's what a circle is, equal distance from the center. Okay, here's some new words. Everybody's looking at number 3, right? It says chord. What's a chord? I bet you may have not heard this word before, but you got to know what it means now. A chord is a segment whose endpoints are 2 points on a circle. So it says the word segment, so it does not have arrowheads, okay? So again, a chord, if you look down here at this picture, it has an endpoint and an endpoint, and it goes through the circle. Does everyone see what a chord is? A segment with endpoints on the circle. Okay? It's got it right here. All right? Number 4, another new word is secant. Okay? Secant. A line that intersects a circle in 2 points. Notice how this one says line. The first one said segment, and this one says line. Lines have arrowheads, right? Is everyone looking up here? So, a secant is a line. So check it out. You see these arrowheads right here? It goes through the circle somewhere, and it's got arrowheads on both sides. That's a secant. Does everyone see what a secant is? If you can't see the secant, then you got to open your eyes. Get it? Can't see, secant. All right, so number 5, diameter. Hopefully we know what a diameter is. Old news. Okay, but a diameter is a chord. A chord, what's a chord? A segment, right? So it's a segment that passes through the center. So here's my center, and here's my secant. That's a diameter, right? Basically, from one edge of the circle to the other, but it has to go through the center, okay? I want everyone to see with your eyes. The chord does not have to go through the center, but a diameter does have to go through the center, okay? Next word, tangent, a line that intersects a circle in exactly 1 point, okay? So notice, it is a line with arrowheads, but it touches the circle at exactly 1 point. So look over here, I got my tangent line, right? So you see how it's on the edge of the circle? Tangent. Y'all ever heard the phrase going off on a tangent? Never heard that. Wow. Okay, well, maybe old people say this, but like, if you're like talking about something and you start talking about something completely different, that's not related to what you were talking about, you know, kind of going off into another world. What? What? Okay. Some people who may be older than you would say going off on a tangent. Well, it's because geometrically that's what you're doing. You're, instead of staying within the circle, you're going off topic. Okay. So, anyways, a tangent is on the edge. Secant and chord go through it. Okay. See the differences? Okay. Minor arc. A minor arc has a measure that is less than 180. Okay. So, minor, less. Makes sense, right? Less than 180 means it's less than a half circle, okay? So if you look right here, minor arc, does everyone see that's less than half of the circle? It's just a little arc, okay? But a major arc is greater than 180. So notice, the major arc looks like the same picture, except, if you look right here, we're going the other direction. We're going the long way. The major arc goes the long way. That is a major arc. It's more than half of that circle, right? So minor arc is less than half. Major arc is more than half. That's pretty much it. This is geometry, not real life. The point of learning it, to get good grades and move on with your life. So, as much as I love this question, since we've been there together, you go to the weight room, right? You lift weights, right? When are you going to lift weights on the football field? You're not. You're going to use the skill that you learn in the process. You trust the process. So I'm telling you, trust the process. And the point is problem-solving skills, okay? If you can be smart enough to problem solve in a circle world, then out in the real world, I think you'll be all right. Though it's not the exact same thing. Just like the weight room is not the football field or the baseball field or anything else, all right? So, that's my takeaway. Moving on. A semicircle is not less or greater. It's exactly half a circle, right? So a semicircle is an arc whose endpoints are the endpoints of a diameter. I don't have a picture of it, okay? But if I were to draw a semicircle in blue, it would be like from here to here. Exactly halfway, right? Semicircle. All right, and then an inscribed angle, okay? So inscribed angle is an angle formed by two chords in a circle that have a common endpoint, okay? So we're going to get to describing what a inscribed angle is. Let's do it in green, I guess. Inscribed angle. It's connected by two chords. It would be something kind of like this, okay? That's inscribed. It's an angle inside of a circle, right? And the common endpoints form the vertex of an inscribed angle. Number 11, this is important, point of tangency. So if you look at your picture, does everyone see right here? Point of tangency is where that tangent line touches that circle, okay? So again, tangent touches at a point of tangency. Now we just front-loaded all this vocab, and you can always refer back to this if and when you're like, what's a secant, what's a chord, what's an arc, or a minor, major arc. Okay, so this is for our information. So let's proceed to talk about properties of tangents, okay? So here we are. Tangent property 1. If a line is a tangent to a circle, then it is blank to the radius, okay? Now, do y'all remember that P word whenever you have lines that make a right angle? It's not parallel, it's the other one. Perpendicular, okay? So if it makes a right angle, like a tangent line does, it's called perpendicular. Perpendicular. If a line is tangent to a circle, then it is perpendicular to the radius. Does everyone see the 90 degrees right here? Oh yeah. So it says to the radius drawn to the what? And so where do they intersect? Point A is kind of like what we had up here. It's called the point of tangency. So again, tangent line is perpendicular at the point of tangent C, right? So we're going to use that information to do some examples. Here you go. Example 1. The radius r equals 3. Find missing leg B. Okay. Now, what do we know about radii? What do I know about this and this? Are they the same or not? They're the same, right? And it tells us that they're what? 3. So guess what? 3 and 3. Cool. Now let's think about it. I got a right triangle because it's a tangent line. What is this whole length right here if I got 3 and 6? Let's add those up. What do we get? 9. So really, since I knew R was 3, I plug it in. I got 3, I got B, and I got 9. So I'm going to have to find that missing leg using our favorite thing, which is Pythagorean Theorem, right? So, if I were to redraw it over here, just to make it look nice, I got 3, I got 9, I got X, right? So, let's do Pythagorean Theorem. 3 squared plus X squared equals 9 squared. Does everyone agree 3 and X are the legs? Since those are the legs, those are on the left side of the equation. That's A and B. And then 9 is the hypotenuse. That's the C. So let's do this. 3 squared is 9. 9 squared is 81. Subtract my 9. And I get X squared equals 72. And then I need a square root, both sides. Square root of 72. Now, thank goodness we got our old new calculators, whatever you want to call them. We got them back, right? Yay! So square root 72. 8 we'll round it to 5. So my missing length 8.5. We did it. That's it. Example 2 is the same dang thing. Can we do it? Yes, we can. So, example 2, the radius is 4. So, this radius and this radius are 4 and 4, right? So, that means this whole length is really 6 plus 4, 10. So it's really a 4 and a 10 and we'll call this Y. The reason why I don't want to use X is because they already had an X for the radius. I'm not looking for the radius. I know what the radius is. I'm looking for, you can call it B, you can call it whatever, okay? It's a variable, okay? And that's what we're looking for. So let's set this up. 4 squared plus Y squared equals 10 squared. Do we know 4 squared? 16. Do we know 10 squared? 100. Minus 16 on both sides. That gives me 84. What's my last step? Square root. And what is the square root of 84 but 9.17? Okay, so if you had a problem like that on your assignment, could you do it? You have 2 examples to look at, right? Now flip it over. Let's try property 2. If 2 segments are tangent, does everyone agree that BA and BC are both tangents, right? They're both off the edge of a circle. It says if they are tangent to a circle from the same external point, which is right here at letter A, then the segments are the same. They're congruent. So I'm going to put little tick marks on here. That equals that if they're both tangent, touching at the same point. Right? Everyone's writing this down? Alright, so if we know that, we look at example 3, and we're supposed to know something about this and this. What do we know? They're congruent. Tick, tick. If they're congruent, I take those measurements and I set them equal. Let's do that. 5x minus 28 equals sign 3x. Now, it might have been a little bit since we've done some straight up algebra, solving for x. But that's okay. Let's remember how to do this. If x is on both sides, what's my strategy? Do I combine them or do I get rid of the smaller one? We get rid of the smaller one. It cannot be on both sides of this equal sign, so I'm going to get rid of the smaller x. Now that means I'm going to get rid of 3x, which is going to be weird for a second, okay? So minus 3x, minus 3x. A lot of people, when they get rid of the only thing on one side, they freak out. Don't freak out. If I eliminate everything on the right side of the equal sign, what should I put there? Not x. X is gone. 3 is gone. There's literally nothing there, and what's the number for literally nothing there? 0. All right. 5x minus 3x, straight up 2x, bring down minus 28. Now we have a two-step problem on the left-hand side. What do I always get rid of first? The loner, minus 28. What's the opposite? Plus 28 on both sides. And now that 0 will be gone. Yay. So bring down 2x, equal sign, 0 plus 28 is 28. Last step, to get rid of that 2, what do? Divide. Okay? 2 is a coefficient, so you divide to get rid of that number in front of the x. So 28 divided by 2 is 14. All right? So if I plug 14 back into both expressions, I'll get the same number. It's going to be congruent. Okay? Let's try it on this next one. What do I know about these two segments? Since they're both tangents touching at the same point, yeah, they're congruent. So I take those two values and I put a equal sign between them. Right? In the back. On that phone? Straight up. Let's write this down. 2x squared plus 5 equal sign 13. Now, x squared is kind of weird. But don't worry. Let's just do what we're supposed to do. What do I get rid of first on the left-hand side? The loner, which is 5. How do I get rid of that positive 5? The opposite is minus 5. Minus 5. 2x squared, bring that down. 13 minus 5 is 8. Now don't touch that squared yet. First, get rid of that coefficient 2. How do I get rid of this 2? Same way I did it up here. Divide by 2. Divide by 2. So x squared equals 4. And now that x squared is by itself, how do I get rid of the squared? Square root sign. Okay? So when you have that x squared problem, wait till the very end, square root it. Hopefully you know, what is the square root of 4? Okay, the positive answer is 2. So that works for me. X equals 2. Okay? So even these squared problems are doable. Okay? Example 5, we'll do it real quick. Again, two tangents, common endpoint, those are congruent, set them equal, 3x plus 10 equals 7x minus 6. X is on both sides. Do I combine them or get rid of one? We get rid of the smaller x, which is 3x. Minus 3x, minus 3x. Bring down the 10. 7 minus 3 is 4. Now, even though x is on the right side, we can still solve it. The loner is on the right. This minus 6 has got to go. Plus 6, plus 6. So I get 16 equals 4x. And again, to get rid of this coefficient, divide, and 16 divided by 4 means x equals 4. Okay? So, we're getting back into using our algebra skills that we cannot forget, especially if we're doing Algebra 2 next year, or any other class for that matter. Our algebra skills gotta stay strong. So, the assignment I'm giving you, the first 7 problems are vocab. So if you look at the first part of your notes that we talked about, you got the vocab, you can identify this stuff, it's multiple choice, and then the rest of them are just like the notes. You're applying the properties of tangents, okay? You can do it. Okay, so let's go ahead and get started, please.